right, geometry, let's look at section 10.4, which is inscribed angles and polygons. And I guess if we're going to cover this, you need to know what an inscribed angle is. So an inscribed angle in a circle is any angle whose vertex is on the circle itself and it contains two chords of the circle. So you have to go all the way across the circle to at least the opposite side. And sometimes we will draw it extending on out of the circle. But that is an inscribed angle. And an inscribed angle will create an arc on the opposite side, and that arc is referred to as the intercepted arc. So if you have the angle, it creates an intercepted arc. Or if we already have a reference to the arc, you could say that the arc subtends the angle. So those are two words that talk about the relationship between the angle and the arc or the chord. You could say that the chord AC is subtending the inscribed angle B. And then we also have inscribed polygons and circumscribed circles. An inscribed polygon is any polygon who has all of its vertices on the circle itself. It does not have to be a regular polygon. The one that we have here is a pentagon, but they could be irregular, and they could be quadrilaterals, could be triangles, any polygon. And the circle that goes around that polygon is called the circumscribed circle, and it does contain every vertex of the polygon. Moving on to a few theorems. The first theorem is talking about the measure of an inscribed angle and how it relates to its intercepted arc. And it turns out that if you have the measure of an inscribed angle, that inscribed angle is always half of the intercepted arc. So for example, and I'm going to erase this pretty quickly, if this angle were 50 degrees, then I would know that the intercepted arc is 100. The angle is half of the arc, or you could say the arc is double the angle, or I could say that the measure of arc AB is twice the measure of angle ADB. Okay. So there's that one. I'm going to erase the 50 and 100. So there's the relationship between the inscribed angle and its intercepted arc. Or if we have two inscribed angles, like we have down here, angles C and D right here, if two inscribed angles happen to intercept the same arc, and they do, they are both intercepting arc AB, even if I do not know the measure of the arc or the measure of the angles, I do know that the angles will be congruent. So two inscribed angles that intercept an arc, intercept a common arc, will be congruent to each other. Moving on. If you have a right triangle inscribed in a circle, so we have inscribed a right triangle in the circle, the hypotenuse of that right triangle will always be the diameter of the circle. And conversely, if one side of an inscribed triangle is the diameter, then we will know that it is a right triangle, and that would be a right angle. Now, the reason that makes sense to me is is related to this first theorem here. If this is a diameter, then I know that this arc right here represents a semicircle and is 180 degrees. And this inscribed angle, B to A and B to C, or angle ABC, is always going to be half of its intercepted arc, which would make that 90 degrees because it's half of the 180. And so if you forget this theorem, if you're going rote memorization, you forget it, you can figure it out by channeling this theorem where the inscribed angle is half of the intercepted arc. And then the last one, if you have an inscribed quadrilateral, the opposite vertices, the opposite angles of the inscribed quadrilateral will always be supplementary. So angle A and C, they're opposite each other in the quadrilateral. They must add up to 180. Angles D and B, opposite each other in the quadrilateral, must add up to 180. They don't have to be congruent. There does not have to be a right angle. We simply know that opposite angles are supplementary. And we're ready to do some examples. And so number one, we're looking for the measure of arc AC. And I noticed that in this case, we have the measure of an inscribed angle that generates that arc. So this is the intercepted arc. And the intercepted arc is always twice the inscribed angle. So that's going to be 2 times 70. And if you're really smart, you would know that's 140 degrees. Number two, I think we suddenly ramped up the difficulty a little bit here. Number two, we have these two angles. We have this angle at E, this angle at B, and I am noticing that both of those angles, if you follow the rays that are creating those, that or the sides of those angles, they both intercept this same arc from D to C, which means those two angles are actually congruent to each other. I can mark them with each with one arc, which means 2x squared minus 2 is equal to 10x minus 2. And I see x squareds and x's in a single equation, which means we want to solve this by factoring. I'm going to move that 10x and this 2 over, so minus 10x plus 2. And this one's pretty nice as far as factoring is concerned because the constant 2 goes away. We're left with 2x minus 10x is equal to 0. 2x squared minus 10x is equal to 0. And when you're factoring, you should always look for something common that can be divided out. I noticed that 10 and 2 are both divisible by 2, so I'll factor out a 2. I have an x squared and an x, so I will divide out an x. And I know that 2x times 1x is 2x squared, and 2x times 5 is 10x. And so when I do this, I end up with two factors. 2x times x minus 5 is 0. 2x would need to equal 0. X minus 5 would need to equal 0. I have my 5 there. There we go. 2 times x equals 0 means x would be 0 over here. X would be 5. And you should always, it's not a bad idea to check your answers all the time in geometry, but definitely when you're solving by factoring. And so what I'm going to do is I'm going to plug these values of x in and see if we have any issues here. Starting with 5. If I plug in 5, 10 times 5 is 50. So if x equals 5, 10 times 5 is 50 minus 2, that will be 48. That'll lead to 48 degrees. 2 times 5 squared, 5 squared is 25, times 2 is 50, minus 2, that would also be 48 degrees. They are equal. That checks out. So I'm going to keep the 5. If I plug in 0, however, I would have 10 times 0 minus 2, and I would have an angle measure of negative 2 degrees. If I plug in 0 here, 2 times 0 squared minus 2 is also negative 2 degrees. The problem is we can't have a negative angle measure, at least in this class. Now, there's some bizarre maths later on in life where a negative angle means something, but in this class, we're going to say a negative angle doesn't make sense. We're going to throw that out because we cannot have negative angles. So we will keep only the answer of x equals 5. Cool. That was fun. My writing is absolute garbage. That's what happens when I do this at the end of the day. All right, so we need to find A and B here, and I'm trying to think of ways I can do this. Let's see. What do I want to do first? I think I'm going to get B first because I see that the angle B is opening up and intercepting this arc on the opposite side of the circle, and the intercepted arc is 140, and the angle that intercepts the arc is always half of that arc. So B is going to be half of 140. What happened to my 1 there? Which is 70 degrees. So B is 70. And see, I need to get A now. There's a couple of ways we could do this. I think I'm going to do this. If B is 70 and this angle is 80, then this angle right here is going to be 180 minus 70 minus 80, which is going to be 30 degrees. So this angle is 30. And that angle is intercepting the arc that is A, and therefore the arc is going to be double the angle. So A is going to be 2 times 30, which is 60. Good. The other way you could have done that is you could have looked at this 80 degrees, and that 80 degree angle intercepts this big arc over here. You could conclude that this arc is then 160, twice that angle, and then A would be 360 degrees minus the two angles, two arc measures of 140 and 160. So there's usually more than one way to solve these things. I just happened to go by finding the third angle of the triangle. Going on to number 4. Draw some barriers here, separate my work. All right, so number 4, I need A. Oh gosh, there's 3 of them. Blech. All right, so I need A, B, and C. A is going to be the easiest one because if you have an inscribed quadrilateral, opposite angles will be supplementary. So I know A plus 98 is going to be 180. A is going to be, I should not do this in my head, 82. I think that's right. Yes. A is going to be 82. And then I need B. How am I going to get B? How am I going to get B? Let's go ahead and get C. I'll see how I can get angle C. This angle right here, 76 degrees, opens up and intercepts this whole angle or this whole arc. So this arc that I'm about to highlight blue is going to be double the angle 76. So 2 times 76 would be that whole arc, and that whole arc would be C plus 34. And so we can go to a calculator and punch that in. All right, so now I'm going to solve this, and C is going to be 2 times the 76, and I'll go ahead and subtract that 34, and I get 118 for C. So C is 118. And for B, I'm trying to see if there's a nicer way to do B. And I think we're going to have to do a little bit of prep work before I can do part B. I'm looking at this angle 98. 98 times 2 is 196. I'm double checking that. And it is. So 98 times 2 is 196, which means the arc that 98 degrees intercepts, which goes from here all the way to here, so this whole arc here is going to be 196, but this is 18 of that. So what I'm going to do is I'm going to make note that this piece is going to be 196 minus 118. I'll throw that in the calculator because I'm not going to make some stupid mistake and end up messing this up. So 196 minus 118, I didn't need that. Gives me 78 degrees, 78. And then finally, I can get B by subtracting all of those other arcs from 360. So 360 minus 34, minus 118, minus 78. And we'll throw that in the calculator and get the answer. And in punching that in the calculator, I just noticed a mistake in my writing. The answer does end up being 130. I put parentheses here. I meant to add all of those and subtract the sum of those. B does end up being, I just lost it, 130. So a little bit of work there to get B. And maybe there was a faster way. I just didn't see it off the top of my head. Moving on. Okay, looking at number 5, solving for A and B. So first thing I notice is that A is the arc intercepted by this 60-degree angle. Therefore, A is going to be twice of that 60-degree angle. And A is going to be 120. And B, and I'm kind of working the long way around the world. I could have done this a couple of different ways. But if I know that A is 120, oh, never mind. B is different. Okay, so B, notice B is opening up to this arc that goes all the way from P through T to S. And so my arc from P to T to S, that looks like a minor arc, and it is. So arc PS is going to be 120 plus 30, which is 150. And so if 150 is the measure of the arc intercepted by angle R, then B is going to be exactly half of that, which will be 75. So there's your B. Number 6, we need arc DG. And to get DG, I noticed that DG is the arc intercepted by the inscribed angle of 40. Therefore, DG is going to be twice of 40, also known as 80 degrees. And then angle G is the angle that is subtended by EF, and EF is 58. Therefore, its subtended angle would be half of that 58, which is 29. Moving on to 7. It says find HML. So HML is that big arc. And I noticed that that big arc is intercepted by the known angle of 109 degrees. Therefore, ML, that arc is going to be twice the 109, which is 218. See, what do you notice about HJL and LKH? So HJL is this angle, and LKH is the 109-degree angle. They both intercept the same arc. Therefore, those two angles are congruent. And for the purpose of speed, I'm going to type that one out because my writing is not always the best. Both angles HJL and LKH intersect the same arc, ARK. Okay, intersect the same arc. Therefore, those two angles are congruent, which means that angle HJL is also 109 degrees. Cool. Are we good? Are we good? All right. Onward we go. If angle C is 68 degrees, what is angle B? This is a quick one because angles C and angle B, they both open up and intercept the same arc, AD. Therefore, they are congruent, and angle B would be 68 degrees. Not a whole lot to that one. Okay. Find the measure of the darker arc or angle. Okay, now y'all's is going to be highlighted. Mine's nice and color-coded. So for me, it's the red arc or angle. So if I want to find this angle, that is an inscribed angle that opens up and intercepts an arc measuring 90 degrees. Therefore, angle HGF is going to be half of 90 degrees, which is 45 degrees. Number B, TV, that is the intercepted arc for the 38-degree angle, and therefore TV is going to be double the angle that is intercepting it. So twice of 38, twice 38 is 76. And this angle, ZXW, that angle intercepts the exact same angle that is intercepted by the 72-degree angle, and therefore those angles must be congruent as well. So therefore, angle ZXW is 72 degrees. Man, my writing. 72 degrees. There we go. Cool. Shiny, happy people. Onward we go. I think this is it, isn't it? Yep. All right. Last four, find the value of each variable. So here I see an inscribed angle. It is opening up to the diameter. That means that will be a 90-degree angle. And the other way you could figure that out is that a diameter creates a semicircle, which is 180 degrees in measure. And the angle that intercepts 180 degree, the inscribed angle that intercepts a 180 degree arc would be half of that. 5x is going to be 90. X is 18. And we are only finding the variable. Always double check instructions. Don't stop with just the variable. It's because sometimes, quite frequently, you need to find the measure of the angle. At number 11, we have an inscribed quadrilateral, and in an inscribed quadrilateral, opposite angles will be supplementary. So B plus 65, I'm going to start with B because that's going to be a little bit easier, is going to be 180. B is going to be 115. And 3A plus 11 plus 111. Did I say 11? I don't know what I said. 3A plus 111 is 180. 3A is going to be 79, and A is 79 divided by 3. That doesn't divide nicely. Did I do that correctly? I'm going to double check my math there because nothing wrong with fractions. I mean, they have feelings. We need to respect fractions. But when I get one, sometimes kind of makes my lips curl up a little bit. So 180 minus 111. Oh, yeah, that's 160. That's, yep, there's my mistake. There's my mistake. It's going to be that number, which shall not be named. Then divide by 3, and 3 divided into that is 23. That's a little bit better. That's why I use calculator. Hey, number 12, we have an inscribed triangle, and one side of that triangle is the diameter, which means this angle X is a 90-degree angle. And if that is a right triangle, the acute angles will be complementary. Y plus 40 is 90 and Y is 50. And almost done here. Opposite angles will be supplementary. So for number 13, I know that X plus 82 is 180. X is going to be 98. And Y plus 68 is also 180. And Y is 112. Yeah. And then we'll wrap up this by interesting. Okay. Yeah, 14 is an interesting one. All the rest of the problems I look at and I was like, hey, I know exactly what I'm going to do. And I know what I'm going to do here, but something is standing out about this one that's really interesting. I'm going to solve for C first. So C equals 2C minus 6. And you add the 6, subtract the C, and you get 6 for C. And if C is 6, that means this angle right here is 6 degrees. This angle, 2 times 6, what in the world just happened? They're not equal to each other. What am I doing? Oh my gosh. There's supplementary. Holy cow. That was embarrassing. Don't tell anybody you saw that. There we go. We'll set those equal to 180. 3C minus 6 is 180. So 3C is 186. And C is going to be 62. Yeah, that's a lot better. So C is 62. So if this is 62, that means this one is 2 times 62 minus 6, or it would be 118. So we have those two angles. Now we're left with the task of solving for X. And what's jumping out at me is I want to do the exact same thing I just did. I want to say that 10X is equal to 8X. The problem is, I just keep setting them equal. Never mind. I'm really having a bad brain day. I wanted to set them equal to each other. But we don't do. They're supplementary. This is everybody has these days. Everybody has these days. All right. They're supplementary. 8X plus 10X is 180. And this is a nice problem. It's not bad. I don't know where my brain was going, why I thought they were going to be equal to each other. 18X equals 180. And X is 10. Holy cow. I probably should re-record that because that was embarrassing, but I'm not starting over. All right, that was it. Have fun mathing. Have a great weekend.